So, good morning to all. I am Romila, Assistant Professor of Department of Information Technology. The subject code is CS3452. The subject name is Theory of Computation. The regulation 2021. The core outcome of theory of computation: CO1, construct automata theory using finite automata; CO2, to construct models of regular expression and languages; CO3, to design context-free grammar and push-down automata; CO4, to understand Turing machines and their capability; CO5, to understand undesirability and NP class problems. And the syllabus for theory of computation: CO1, automata and regular expressions; CO Unit 2, regular expression and languages; Unit 3, context-free grammar and full-stone automata; Unit 4, normal forms and Turing machines; Unit 5, undesirability. So the final topic of first unit, minimization of DFA. When the minimization of DFA means this process of reducing the number of states in deterministic finite automata without changing the language it accepts. So steps to minimize DFA, it's a table filling method is an important one. So step one is remove unreachable states. Eliminate states that cannot be reached from the start state. So step two, separate final and non-final states. So first one is divide states into two groups. One final states, another one is non-final states. So any pair consisting of one final and one non-final state is not equivalent. So step 3 is create state pair table. So list of all possible pairs of states. Marks pairs as a distinguishable of X if one is final and the another is not. So step 4, check transition for each unmarked pair P comma Q. Compare del of P comma 0 with del of Q comma 0. Compare P comma 1 with del of Q comma 1. The if transition lead to a pair that is already marked distinguishable, then mark P comma Q as distinguishable. So repeat until no new marking occurs. So step 5, from equivalent states. Unmarked pairs are equivalent. The merge equivalent states to from new states. And then step 5, construct minimized DFA. Each equivalence class becomes one state. The start states may equal to class containing original start state. The final state is class containing original final states. Update transition is accordingly. So the example for minimization DFA given below. So the states are 9 states in the given transition table. The input symbols are 0 or 1. So A going to 0 and 1 symbol is B. B going to 0 and 1 input symbol of CF, and C also a final state, and 0 1 going to DH, and D going to 0 and 1 input symbol is EH, and E going to 0 1 input symbol of I. So F is a final state, and then 0 1 going to input symbol of G B O C, and going to input symbol of HB. So H going to input symbol of IC. So I also final state. So 0 1 input symbol going to AE. So given the problem is solution. The solution means distinguishable and indistinguishable states are, if for some input string is W, so del of P comma W gives an accepting state, and del of Q comma W give a non-accepting state. So or vice versa, then states are P and Q are called distinguishable states or non-equivalent states. So if for some input string W comma del of P comma W and del of Q comma W both produces either accepting states or unaccepting states, then states P and Q are called indistinguishable or equivalent states. So we will apply a table filling method or minimizing the given DFA. So the diagram means, so first one, the transition table, first vertical lines are second line to last given. So on the horizontal line means first line of start state to last two steps of input states were and stop. So the C and the int mark means, so final states are marked. So we will mark x in final and non-final pairs. Now we will consider each pair and check for its equivalence. Consider for of GH. So GH means del of G comma 0 equal to h, and del of G comma 1 equal to b, and del of h comma 0 equal to I, and del of h comma 1 equal to c. Since the pair of h comma I and b comma c is already marked, so x marked in x pair gh is not equivalent, so we will mark x in gh. So step 3, now we consider pair EH. So EH followed by 0 and 1 input symbol is FI and IC. So FI and IC both are final states. Hence pair E and H is said to be equivalent, and we won't put X in the pair of EH. So now is considered EG. So EG goes to 0 and 1 pair FH and IB. So step 4, FH and IB and have X. So we put X in EG. So consider pair of EF and the E comma 0 and F E comma 1. F comma 0, F comma 1. So is the pair of EG, FG and IB. So put X in pair EF, hence table will be, the table will be, and the int mark is allowable by the mark states. And consider pairs T comma H, D, G, D, F, D, out of which del of D comma 0 and del of H comma 0 equal to EI, and the del of D1 comma H and del of H comma 1 equal to C. So in the pairs of put X in DH. So in the pair of E comma H is equivalent. For pair HB is a will find their input transition. Both states H and state we yield the final state. We say pair D comma H. So equivalent the same string find pair HP as equivalent. So del of D comma 0 equal to E, del of D comma 1 equal to H, del of F comma 0 equal to G, del of F comma 1 equal to P. So as pair of EG is having a int mark, so we will put in int mark is DFA also. So consider pair D, BG and BF and CG having a int mark. So put X in BF. So consider a new pair of BE. The input symbol of zeros are 1. So CF and IFI are both final states. We say pair B and is equivalent. So consider pair DP and EC, and then BI also put a X into mark. So these given states are also put into mark. So consider pair of AG. The means 0 and 1s going to BH and BE are equivalent. So we can say pair AG is also equivalent. So we can say pair AG is equivalent. So consider a pair A comma E. So A comma E going to 0 or 1s in the BF and the EI. So have BF have a X. We will put an X in AE. So pair AD is already equivalent. So consider a pair of AB. So AB going to zeros or ones, BC and EF. And BC have a X. We will put in X in also AB. So the hence finally table will be the given put int mark is available by the table filling method. So the blank entires present equivalent states are states AG equal to D, A and state B equal to H equal to E, state C equal to I equal to F. It's reduced by will be first the given below question is 9 input symbols states. So reduced by minimize DFA. The state means 3. So A, B, C. C also final state. So zeros and 1 input symbols going to A, B, 0 is going to B and A 1 goes to B and B goes to C and 0, and B goes to 1 means C, and C final state is going to 0 means A, and C goes to 1 means B. So in the input transition table given by the draw a final minimized DFA transist diagram is here. So in start symbol CA, C is a final state. So B goes to 0 comma 1, and then B goes to C equal to 0 comma 1, and then C goes to 0 is a C goes to 1 input symbol is a B. So thank you so much.